about 5 seconds. Okay, or not. Just gotten stuck. Try this again. It's being weird. It's stuck. It's the first time this has happened. I'm not sure. I talked to Calvin Winkle. All right. Welcome back, everybody, to track 3 of the Python WebConf. This is day 3. My name is Josh Qualls. I'm the Community and Partner Manager here at 6 Feet Up. I'm joined by Moshe Zadka. He's going to be talking about, incrementally developing your web app with Jupyter and Klein. I know we went a little bit over there on the keynote, so Moshe, I want you to just kind of grab it over and get going.
Thank you, John. Okay, here. Yes, so I'm going to talk about interactively writing web applications. How to imagine the world of web development with Klein and Jupyter. My name is Moshe Zadka. My website is cobordism.com, where you can find links to every single way to contact me known to humankind, including my email, my Twitter, my GitHub, my LinkedIn, etc. Okay, and I guess before we start, I want to talk about what it means to have an interactive development environment. And there's a lot of things that call themselves interactive development environments. And I want to point out that it's an editor, right? They're all editors that have a button that can run Python or some other program, right? It's like the scene in Toy Story that says, you're an editor. It's just an editor, right? If you actually heard the words interactive development environment and you never used any of those things, and someone told you, hey, your job is to make an interactive development environment, you would be making something very different. You would be making an environment that allows for interactive development, right? Where you can develop a little bit and see how it works. So instead of interactive development environment, what we have in a lot of web development stuff is auto-reloading, where as soon as you save a file, it will reload. This is, of course, very complicated and fragile, uses operating system hacks to figure out when a file in a directory. Your application has basically constant downtime. Literally every time you save a file, it restarts. And while it restarts fast enough for humans, usually, unless your application takes a long time to start up because it's doing something at startup, it's often like, if you actually like automate, like, hey, let's open a window as soon as we reload, you can't trust it because it takes time, right? So is it reloaded? How about now? Did you try it too fast? Do we need to put it to sleep? So it's not a good solution to actually see how your application responds to code changes, which is the only thing you should care about if you're writing web code. So I'm gonna write a web application during this talk, which at each step will be usable, and I'm not gonna reload once. So to do that, we need to use some powerful tools. And I'm gonna use two of the most powerful tools I know, which is Twisted and Jupyter. So kind of let's go over the theory of how it works. Klein is a web framework, but it's running on top of Twisted, which is a networking framework. Twisted has a bunch of potential reactors, which are the event loops it runs. And one of them is the async IO reactor, which runs on top of the async IO event loop. Now the Jupyter kernel, and this is kind of like one of the critical facts that I think many people, even if they've been using Jupyter for a while, are not aware. Jupyter just runs on the async IO event loop. So if we just tell Twisted to run on top of the async IO reactor, we'll have Twisted and Jupyter sharing an event loop. And that's actually pretty easy. We just import the right async IO reactor. We run it, that's done. So, well, in real life, if I was actually interactively developing a application, I would be inputting things as I need them. But that would be kind of boring. So, well, in Lisp, obviously, every file ends with a long string of close parens. In Python, anyone who has written even a little bit of Python knows that every file starts with a long string of imports. These are all the imports I'm going to need for the rest of the talk. And now we start, again, putting things together. So Klein, like I said, is a web framework. It doesn't understand network, right? It understands how to think about HTML and about HTTP and how to send these things, but it doesn't actually know how to connect to a network socket and send this. Endpoint knows how to send stuff over a network, but they don't understand content. They don't know what HTTP is. They don't know what the HTML file are. So we're gonna have them putting together and have the endpoint and the resource combine. They'll use the site, which is part of the server, to kind of actually communicate with each other. And that's it. I've written a web application. Now, I haven't done a lot of work, right? So it's not going to be a very interesting web application, but this is a web application. So let's check it out. Typically, you check out a web application using a browser. Luckily, I have a browser right here. So let's open a tab. And it's a working web application, right? You might be disappointed it doesn't do more. Literally, the only thing it does is send you a 404 not found. But it works, right? I connected to the port I needed. It didn't know how to respond because I didn't do a lot of work. Let's face it, this is only the beginning of the talk. So it gave me a 404. So usually if you're developing a web application and you get a 404 to a link you really wanted to go, it means you made a mistake somewhere, right? It's a failure, right? But we'll have to go on through. And as always, like any good business manager, instead of calling it a failure, we'll redefine success. Because until today, you might have thought I was in the web development business. But that's not the business I'm trying to convince you that you should be in. We're in the incremental web development business. So what does success looks like in the incremental web development business? Well, success looks like incrementally developing the web application, which means if at any step I do more than the minimum that I needed to get the next thing working, I have failed, right? I want to, each step, do work that's a little bit and then get a little bit of gain. So after convincing you a lot that like my 404 was not a problem, I do want to actually have some content at some point. And of course, we turn to the CS roots and choose the first content to be hello world. Um, so without further ado, hello world, right? And again, remember, it's the same URL. We have not restarted the application, but now we have content. It's not very useful content. It's just saying hello world, but it's no longer 404ing. It responds with the content we hoped it will. So that's great, right? We're making progress, and at each point, we're doing a little bit of work, and we're getting a little bit of value in return. So let's move on. One page is not very interesting. Let's add another page. But of course, we don't want to actually type URLs, right? So that means we have to change the slash page to have a link. And we change the slash page. And now we have a link to the about, and we got the link to the about page. Wonderful, right? So we did a little bit more work. We just added the about page and we changed welcome a little bit. And we got what we wanted. Awesome. So again, I want to stress the point, right? The root page slash before just had the hello world content. I changed it from having the hello world content to have hello world content plus a link, and it changed immediately. I didn't have to make any complicated restart, reload. You saw I had the import, the web browser that opened right there, and I could trust it. I could trust that it didn't have to wait. But of course, if we just wanted a couple of static pages with hello world and about, I would have just dumped HTML files and used something like Nginx to serve them, right? The point of writing a web application, the point of going through all this effort is that you can do stuff. You can dynamically do computation and respond to the inputs. So let's do some computation and respond to the inputs. For this, we're gonna add numbers. That's right around the simplest computation I can imagine. Sorry. So let's do that, right? We'll add the number, we'll put an HTML page, and let's figure out what 12 plus 12 is. I'm sorry. So this is 24, right? And granted, I only wrote one math paper, so I can't be sure, but I think that sounds like about right. If you're worried that I just kind of like a total barbarian, just interpolated my result into HTML, that is good that you worry about these things. It means you have either experience or proper training. But that's actually fine and perfectly safe because the route protects me. The route makes sure that number is an int. If you add a number to another number, you can never get anything that looks like HTML or XSS. So this is actually safe, but we will talk about techniques that are a little bit more general. But this, I want to stress that I'm not trying to teach anyone to do bad things. So now, unfortunately, we're gonna have to do some imagining of like an alternate reality. So let me guide you through my favorite alternate reality. That might talk more about me than the alternate reality. And the reason we want to live in real interpretation in an alternative reality is that if I was writing a real application, and I'm sure that anyone who has written a real application, they have a backend, right? Maybe they had a database server, or maybe they had like a microservice that they asked. Maybe they had 5 microservices they had to talk about too. But I don't want to write a backend, right? That will distract from like the main talk. So if you think about it, a demo application should have some kind of mockend. And I want a simple mockend. So the alternate reality that we live in has computation as a service. So in this alternate world, multiplication is a super heavy computational thing. You don't do it on your laptop or even like on a standard server, right? You have special services that specialize in multiplying, and you connect to them and you tell them which numbers you want to multiply, and they take time because it's a very complicated operation, and they respond to you. And in my alternate reality, they take 5 seconds. Hopefully, if you wrote real web application, they did not take 5 seconds. So this is not just an alternate reality. This is an alternate reality in slow-mo, right? And we're doing slow-mo in this talk for the same reasons they're doing slow-mo in movies, right? Want to concentrate on specific things. They want to show how they work, right? So when you see the bullets slowly moving in so that you see the person kind of, right? It's more engaging, right? And hopefully this talk will also use this for engagement. To do a mockend, I'm gonna write a function called delayed multiplication that takes two numbers and then gives you an async result that in 5 seconds will actually have the numbers. And yes, 5 seconds is obviously very slow. But if you think about it, all backends are slow if your users are impatient enough, right? A 0.3 second backend is very slow. If users give up after 0.1 seconds, that would be just really hard to show in a talk because it's kind of hard to show 0.1 seconds and 0.3 seconds and kind of canceling things fast enough while I actually have to talk. So 5 seconds give me time to talk and explain while we're seeing the results. So what kind of things we can do with multiplication? What I like about multiplication is that ideally you've all done some multiplication in your life and you understand what kind of things it's good for, right? And one of the things it's good for is calculating the square of the hypotenuse in a right angle triangle. If you remember Pythagoras' theorem, the square of the hypotenuse is the sum of the squares of the other two sides. Calculating a square is the same as multiplying a number by itself. Okay, so how do we multiply a number by itself? Well, we use delayed multiplication because we can do multiplication locally in our alternate reality. So we get the square of A, square of B. Then we sum them. That is something we can do locally because, like I said, adding is fast enough. Then we interpolate, which should be fine because we're using two floats. So, I talked a lot about this code. Let's try it out. And it's slow, right? Because we're using a slow backend. But is it slower than it should be, right? I'm having to kind of talk quite a bit before we see the results. The results is 25, 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. So it is correct, but it took a long time, right? And this is kind of like the usefulness in slow-mo. You kind of see the time kind of stretched and see that it's kind of painful to use a slow backend. Because a lot of what we're talking about is how to use slow backends better. So if you think about, right, I described the backend as like, some other company writing a special cluster of computation as a service. They're hopefully very good at scaling, but we didn't take full advantage of them, right? We sent them one multiplication request. We waited until they gave us the result, and then we sent them another multiplication request, right? That meant that we took 10 seconds, right? Because multiplication takes 5 seconds. Now, we cannot, there's no way we can write this code that will take less than 5 seconds because we have to do at least one multiplication. One multiplication takes 5 seconds. That is, but we don't have to take 5 seconds. Sorry, we don't have to take 10 seconds. We can just take 5 seconds. And that's kind of like a nice trick that I want to talk about. Because like I said, every backend is slow if your users are impatient enough. And if your backend takes 0.1 seconds and users cannot wait more than 0.3 seconds, then calling it 3 times is just as bad as calling a 5-second backend twice and taking 10 seconds. So here we call delayed multiplication without yield, which means it returns immediately. But of course, it can't return immediately with a useful value, right? Multiplication will still take 5 seconds. So it returns with a deferred, a promise that in the future we'll have a result. And same thing with B, right? But then we don't need the promises, we need the actual values. And what we're gonna do to get those two values will be to use defer gather results, which takes a list of two deferreds or two promises and returns to your promise with two values, right? So it kind of inverts, and that's one of the critical things here, right? We already sent both requests, and we get the sum, and then we get both, and then we calculate the sum, and we interpolate it. And if you notice, right? Again, look that I chose the same URL, and it's much faster, right? I didn't have as much time to talk. I didn't have to kind of make excuses for why I'm kind of like filling in some filler while we're waiting for the results to happen. Yeah, they did take some time, but by the time I kind of actually chatted up a little bit, it returned, but it returned the right result, right? Still 25. So this is great, right? We optimized on the fly, right? Um, our code from a slow backend. Well, you know, the backend is still slow, from using a slow backend naively and taking a long time to using the slow backend better and taking less time. And like all things, it has a trade-off, right? Here, right, again, we start by imagining that you own your own, that you don't own the compute cluster, right? That you're buying it as a service. But what if you owned your own compute cluster, right? You became big enough and decided to buy your own compute cluster. Well, in the previous version of the code, right, you used one at a time, right? And one at a time per user request. This uses two at a time, right? Which means you're potentially doubling the load on the compute cluster. And that's why I kind of put this in the joke that scaling the backend is someone else's problem. And again, this is a real problem, right? It's an alternate reality, but this is also a problem in our reality. When you optimize a front end in exactly this way to send more requests to a backend, and it doesn't matter if your front end is the frontmost web backend or like somewhere in the middle, at that point, when that part of the stack starts doubling the results, and again, imagine that this is not a doubling. Imagine that this is like, you know, taking 5 values for any reason, right? I did this too because this explains the issue. But what if then you can really blow up the load on the backend cluster, and you know, it probably has some limits. And this is a very typical problem. It's a real problem when you do these things. I'm not going to cover in this talk how to put a cap on how much load you're putting on a backend, but that is a correct solution, right? The correct solution is to put an explicit cap on the backend solution, not to just hope that you'll be slowing enough to not overload it, right? You want to say, okay, this is how much I'm willing to spend to send it to. I'm gonna send as much as I can, right? And optimize my code to send as much as it can. And then, you know, maybe if it's already sent 10 requests, then it has to wait until it sends it 11th. But then you know whose fault it is. It's not the fault of yours. It's the fault that you put a cap in front of it. And then you can raise a cap. If you break the backend server, then you have to also scale the backend server. But it's the fault of the backend server ultimately, and a configuration option in your code to not kill the backend server. So in order to make things a bit more interesting, I'm also imagining that negation is very slow. It's a little bit less slow, it's 2 seconds. So we define that. That allows us to do some more computation. And again, if you think about it, this is not that different from our reality, right? In our reality, you often have a few things that you need in the backend. Maybe it's different SQL queries to the same database. Maybe it's using 2 different microservices on the backend, whatever. Like and they have different times, right? And I want to kind of simulate the challenges that you will see if you do that. So again, I will use some fun math, right? So Euclidean distance or Euclidean distance squared, because I didn't want to screw around with square roots. So x1 minus x2 squared and y1 minus y2 squared. This is how you do, find the difference between 2 points on a plane, the distance squared. And this is how you use the code optimally, right? I first negate x2 and x2 and y2 at the same time. I can't multiply, right? I can't calculate the square until I get the results, but I can do both negations at the same time. Then I add x1 to minus x2 to get x1 minus x2. And then I add one y1 to minus y2. So that gives me the y. And then I do delayed multiplication of the number by itself, which gives me x1 minus x2 squared. And same thing with y. And then I do gather results. I add them. And this is going to take some time, right? Because we're doing both negation and multiplication. And like I said, we can't even start the multiplication until we're done with the negation. So we got 25. But this code looked very complicated, right? I had to put a comment with the math formula, which is actually very straightforward, and then kind of open up the math formula to kind of pretty complex stuff, just so I can get a result in good time. And if you write that kind of code, almost certainly someone's gonna put in the code review, hey, why not just write something that corresponds to the math formula, then you won't need to write a comment, it will obvious what you're calculating. So let's see. That seems like a reasonable code review comment. Let's try and see how this works. So this is much closer to the actual math, right? x1 minus x2, y1 minus y2. We calculate the squares. We calculate the squares of y, and we add them, and we put the result, and that's it, right? So this code is much clearer than this code. But let's see how it performs. And I'm not talking, so, oh, yes, I am talking a little bit, but I want to just sit with the pain a bit. Right? It should be uncomfortable, right? And it was uncomfortable, right? Like this took some time. This took a lot longer. And again, this is slow-mo, right? But in the real life, this is exactly what would happen as well. This would be much slower than the other. Now, I can't answer the question if it's really worth it, right? I answered it yes, because in this case, it was clearly worth it. In general, is optimization worth it? I don't know, right? I don't know who is using your web application. I don't know how much patience you have. I don't know how much money you make of the web application, whether it's worth it to optimize. What I can tell you that this is a lot slower, right? The clear code is actually a lot slower. And this is a very typical thing in the part of web application that talks to a backend. If you want to talk to the backend efficiently and not slow down unreasonably when they slow down, you're going to have to do a lot of work here. Okay, so far all my HTML was basically text wrapped up in a little bit of HTML tag. You probably think that this kind of sounds like a little bit of a kind of simplified. So let's write some HTML. So here I'm going to use XML String. In real life, you'll almost always use XML files and have separate files. You could actually do that in Jupyter too, but for mostly explanation reasons, it's kind of easier to explain when like the files are right here, but you can easily put the files next to that. You still add them during Jupyter, but then you can have a designer. And one of the nice things is this is valid HTML, right? It does have the namespace thing, but it's completely valid HTML, even the template. But that's easy because this template doesn't do anything. So let's greet ourselves a little bit. but we're not actually greeting ourselves. We're just sending a generic greeting because we didn't bother interpolating the name that I specified here, who you're greeting, um, to the template. Okay, so let's do that. So let's add a parameter. So we're making an authors class here, greeter, and we're adding an attribute, and then we're calling it with the attribute. So we set it one step. And we still haven't interpolated it, right? So now we have the potential to interpolate. That's good. Let's keep going. Now we're gonna add a render, right? And we will tell it where to render. But unfortunately, forgot the closing greater than symbol. And that's fine because browsers can deal with pretty bad HTML, and sometimes it will give you wide, like really weird results, right? You'll forget the greater than symbol on the greeting, for example, and it will give you everything is in H1 and super big, and you're like, why is this all like scaled up? But that's okay. You deal with it as every application does, except here you don't have to deal with it because it's an XML string. It will make sure that the input template is actually valid XML. And so you don't have to wait until you figure out that the browser is doing something really weird with the HTML to figure out where the error is. Right, and we know, right? It's an unclosed token, right? We made a mistake intentionally, but in general, it's kind of useful to know which line it is, right? So it's line 4, column 8, exactly where this is. So this is wonderful. Okay, so as much fun as it is seeing how really good error messages look like, let's fix it. So I added back the greater than symbol, and whew, okay, that was not what we expected. So let's kind of dig through the traceback a little bit. Missing render method, yes. So I did have a render for name, but I didn't explain how to render name. Okay, that's clearly something we should be fixing. So let's define what name is. We put a render, and we just return the home string. Hello, Python WebConf. It only took us about half the talk to get like a nice greeting to the conference. And that's the magic of incrementally developing web application, right? We kind of incrementally improved things until we got to the point where we actually can send a greeting that is proper. Of course, we just interpolated stuff, right? So if you put like a blink or some JavaScript, you open yourself to things like XSS, except you don't, because we use the rendering framework of web templates to render it, and it knows that this should be a valid XML, and so any inputs here should be properly protected. You can explicitly unprotect it, but that is an explicit choice that you will have to do in code, and you have to kind of make sure that you're validating before that. And more importantly, like anyone who reviews your code can see that this is a potential issue and to see if you've properly mitigated it. By default, it does the right thing, right? By default, it will properly interpolate, so we don't have a blink. That's good. Now let's do some computation, because computation is fun. Let's put how many letters your name has. So we added a little bit of another render, and we added another renderer here. And let's greet ourselves again. Your name has 15 letters, and I'm not going to bother counting. I'm pretty sure that it's correct. So this is kind of fun, right? We again changed, right? The default name was in H2, the count was in letters, and that all looked great. So, you know, that's obviously a very simplistic HTML. I'm sure that the HTML you will write in real life is more complicated, but we're not in an HTML talk. So now let's count the square of the letters, right? So, and the cool thing here is that we can easily have a renderer that returns a delayed result, right? Because this will take 5 seconds, right? Because delayed multiplication takes 5 seconds. But we don't have to bother around it when writing the renderer. So again, these take some time. 5, 4. Okay, and but the square of the name, I didn't change the template, so it's still, as your name has to, you know, your name has the square number of letters in your name has 225 because it was annoying to write. So it's misleading, but correct as far as the code goes. Okay, that's pretty awesome, right? Now let's be 10x programmers, and as everybody knows, the 10x programmers is someone who knows how to multiply by 10. So now we change the template because so your name has a square of letters, and now let's also multiply by 10. So it will have, if you repeat it 10 times, it will have 10x number letters, and then define 10x, which just multiplies the number by 10. And we have to wait a bit because we are using a slow backend. But eventually it will work. Yep, and if you repeat it 10 times, it will have 150 letters, right? So we can use as much as delayed backend as we want. Now, until now, everything that I wanted with dynamic inputs, I put in the URL. That's because that's much easier. Posting is hard, right? Posting is inherently hard. It's not hard in this framework. It's inherently a hard thing in 2020. It used to not be hard in like 2001, a long, long time ago. And that's because of something called CSRF. CSRF stands for something request forgery. And the problem is that someone else can force a user's browser to send you a post. And so they can have a link that surreptitiously basically sends you a post that says, buy from your web store my really bad product for tons of money, and basically get all the users to send you buy requests from the web stores. That's obviously going to be pretty bad because you're paying for something you potentially didn't want to pay. It's obviously really bad. The usual way to fix it is with sessions. So now we have to build sessions just to have forms. This is a modern web. This is not the problem with interactive web development, but we'll have to go through that. Okay, so here's the memory session store. We have a require, we have a prerequisites, we have a procure. That's kind of boring, but we'll have to go through that. We'll put a common style. I'm sorry, I started to talk a little bit late, so I'm kind of going through these things a little bit fast. Here, this is kind of an interesting thing, right? First, we define the post handler, and only then we'll define the post render. And the reason is because the post handler knows what things it needs. It knows it needs a number, and it has a minimum and a maximum, and a text. But we can't just post the form, right? The whole point is we have a CSRF, so we have to actually render the form. So let's render the form. And let's try it out. Okay, so, and we have to wait a bit because, of course, multiplying things takes time. But The name is Python WebConf, the square is 40. So we actually wrote like a full-featured web application with CSRF protection, XSRF protection, forms, everything. And we used a bunch of technologies, right? We used Jupyter, which runs on top of async.io. And we use Twisted, which can run on top of async.io, with Klein on top of that, to get a real interactive development environment for web applications. I hope you all had fun. Unfortunately, I don't think I have a lot of time for questions because we did start a teeny bit late, but we can take questions offline later. So that's it for me. Thank you everybody for listening to my talk.